If the sun could join us on Earth, how would you want it? If you think that's an impossible fantasy, China is here to bust your bubble. A new nuclear sun, modeled after the sun at the center of our solar system, has been created. The latest artificial sun experiment launched by China lasted for up to 17 minutes. This caused its temperature to rise to 70 million degrees, or 5 times that of the actual sun. According to research on China's artificial sun, the energy-generating process of the artificial sun is very similar to that of the real sun. A nuclear fission reactor, like the artificial sun, can produce vast quantities of clean energy with few byproducts. However, how exactly does China's new nuclear sun copy function? In this video, we will discuss the launch of China's artificial sun and its technological power. The unfiltered solar power. The sun is the biggest and most important thing in the solar system, and it also happens to be a kind of life there. Its diameter is approximately 109 times that of Earth, and it contains 99.8% of the mass in the solar system. The sun has enough room for 1 million Earths. Although the sun's surface temperature is around 5,500 degrees Celsius, its core temperature is far higher at around 15 million degrees Celsius. To match the energy output of the sun, one would need to detonate 100 billion tons of dynamite every second. The sun is one of over 100 billion stars on the Milky Way, traveling in an orbit that takes 250 million years to complete and takes it to a point about 25,000 light-years from the galactic center. The sun belongs to a group of stars known as Population 1, which are very young and have high abundances of elements other than helium. It started life 4.6 billion years ago, yet it has enough energy to keep going for another 5 billion. About 63 million watts of energy per square meter are radiated from the sun's surface. At the top of the atmosphere, directly facing the sun, the energy is reduced to 1370 watts per square meter by the time it reaches Earth, after traveling 150 million kilometers. Apparently, China is not content with the solar energy it receives, so it is building a new sun 5 times hotter than the real one in its backyard. The cost of duplicating the sun, however, is enormous, $1 trillion. The aim of creating a man-made sun. Experts hope to provide an almost infinite supply of clean energy by simulating the processes that take place within stars. The artificial sun generates energy in the same way as the real sun does, making it the holy grail of eco-friendly power plants. This is since, unlike nuclear fission, the technology used in commercial nuclear power plants does not necessitate the consumption of fossil fuels and produces no toxic products. There is significantly less potential for environmental catastrophe, according to the researchers. The working of China's artificial sun, it functions similarly to the sun. Nuclear fusion in the sun generates solar power that ultimately reaches Earth. In the core of the sun, hydrogen protons clash so furiously that they fuse into helium. The energy released by the PP, or proton-proton chain reaction, is truly phenomenal. About 620 million metric tons of hydrogen is fused within the sun's nucleus every second. Core conditions with an approximated 250 billion atmospheres of pressure and 15.7 million Kelvin of heat make this response conceivable. The end product of this reaction is an alpha particle composed of 2 protons and 2 neutrons bonded together in the same way that a helium nucleus is. This procedure converts 2 protons into neutrons and energy, while 2 positrons and 2 neutrinos are produced as byproducts. The tokamak and the East architecture. Over the course of 15 minutes, the Sun of China superheated a loop of plasma to temperatures 5 times hotter than the Sun. For a full 1056 seconds, the East reactor, experimental advanced superconducting tokamak, kept a steady 70 million degrees Celsius in its core. The scientific community is celebrating this breakthrough because it brings us that much closer to developing a sustainable energy source with virtually infinite potential. The record was previously held by the French Supra Tokamak Tour in 2003, but the East Asian team broke it in just 390 seconds. In the meantime, a year ago, East ran for 101 seconds at 120 million degrees Celsius, setting yet another record. In order to produce a sun-like object, you must simulate the circumstances found within the sun as well as other massive stars. Tokamak, used by East, is devices that confine plasma within a donut-like form known as a torus using magnetic fields. Scientists working in the field of fusion energy have deemed the tokamak to be the most promising plasma confinement design for a future fusion power plant. Magnetic field coils in a tokamak can locate plasma particles, creating the conditions for fusion to occur in the plasma. Tokamak's central component is a donut-shaped vacuum chamber where gaseous hydrogen fuel is subjected to high temperatures and pressures in order to create plasma. Hot, electrically charged gas is called plasma. Scientists may manipulate the plasma's charged particles with the help of huge magnetic coils set up surrounding the chamber. Maintaining a safe distance between the plasma and the chamber walls requires careful regulation. This is because a nuclear meltdown would occur almost instantly if electrically charged plasma made contact with the reactor walls. The hydrogen gas fuel is ionized, or the electrons are removed from the nuclei when a high-voltage electrical current is passed through the vessel. When plasma particles gain momentum and smash into one another, they generate heat. Is tokamak risk-free? The plasma is heated to fusion temperatures between 150 and 300 million degrees Celsius with the use of supplementary heating technologies. On impact, the particles gain enough momentum to overcome their electromagnetic repulsion and fuse, unleashing enormous amounts of energy. You might be concerned about the safety of tokamak after hearing about all these high temperatures. However, less than 1/10 of a gram of hydrogen fuel is normally present in the chamber of a modern tokamak at any given time. In the event of a pulse interruption, the reaction cools down and stops, ruling out the possibility of a nuclear explosion in a tokamak. Even while fusion is a safe process in and of itself, researchers are taking extra precautions by incorporating many safeguards into fusion power plant designs. So even if there were a catastrophic leak in a tokamak, the radioactivity released outside the plant's containment would be negligible. The major obstacles. How to safely manage plasma at fusion temperatures was a major challenge for Chinese researchers. However, fusion reactors require extremely high temperatures, often even higher than the surface of the Sun, because they must practically operate at far lower pressures than the Sun itself. While it is possible to heat plasma to temperatures higher than the Sun, it is far more difficult to contain it so that it does not burn by means of reactive walls using lasers or magnetic fields, which would have otherwise halted the fusion process. By the time it wraps out the experiment in June, China will have spent 500 billion of the 700 billion it has so far poured into East. Meanwhile, ETA, the International Experimental Reactor being built in Marseille, France, is an even more ambitious fusion project than East. Thanks to what was learned during the East development process, the program now includes 35 countries, including those from the EU, the UK, China, India, and the US. The ETA is equipped with a magnet 280,000 times more powerful than Earth's, making it the most powerful device of its kind on the planet. ETA's creators say that if 50 MW are used to power the reactor's ignition, it will generate 500 MW. The ETA tokamak has a plasma volume of 830 cubic meters, which is an unprecedented amount. Tokamak can only operate with a maximum plasma volume of 100 cubic meters. Its massive plasma volume will allow it to create, for the first time, burning plasma where the alpha particles produced by the fusion reaction provide the majority of the heating required to continue the fusion reaction. More than 50 years of study into magnetic fusion have been directed toward the creation and regulation of such self-heated plasma. When the fusion reactor goes live in 2025, scientists will learn even more about the feasibility of using stellar power here on Earth. The heavy hydrogen atoms in deuterium can, in theory, be extracted from the Earth's oceans. Energy from China's artificial sun is limitless, since just 1 liter of seawater contains enough fusion material to generate the energy of 300 liters of gasoline. China is not putting a stop to it in the East region because it is simultaneously pursuing other initiatives to advance nuclear fusion power and will soon be finished with development of a second tokamak. The benefits from China's artificial sun. China's artificial sun has the potential to unlock a revolutionary source of clean and sustainable energy through nuclear fusion, offering a virtually limitless supply of power. Fusion energy is considered environmentally friendly, as it produces no greenhouse gas emissions or long-lived radioactive waste. The artificial sun could contribute to mitigating climate change and reducing reliance on fossil fuels. Fusion fuel sources, deuterium and tritium, are abundant in seawater and can be easily extracted, ensuring a long-term and accessible energy supply. Fusion reactions have the potential to be significantly more efficient than current nuclear fission reactions, resulting in higher energy output from a smaller amount of fuel. Fusion power plants, based on the principles of the artificial sun, can be designed in various sizes to suit different energy demands, from small-scale applications to large-scale electricity generation. Research on the artificial sun drives advancements in various scientific and engineering disciplines, such as materials science, plasma physics, and superconducting technologies, which have broader applications beyond fusion energy. If you enjoy the content on this channel and want to stay up to date with our latest videos, hit that subscribe button and join our community of like-minded viewers.